Welcome to the show, Simon and Rohan. Rohan, let's start with you. Will you give us a quick intro? Tell us what you do here.
Yeah, hey guys, really excited to be here. So I'm a principal product manager on the Amazon Aurora team. I get to work on really fun things on databases, but one of the core hats that I wear is on high availability and cross-region resiliency. So global database is a fun topic for me to talk to you guys about.
I love it. And Simon, please tell us about.
Thanks for having me. I'm Simon Comendera. I'm a principal solutions architect here at AWS. Been around for over a decade and it keeps getting better. So glad to be here. I work with databases, so they don't let us out much. So thanks for having me.
Same here. I don't get out much either. I think that's on purpose too, Simon. So Fiona and I are going to just pepper you all with some questions here for the next
Get ready for it.
20 minutes or so. I want to kick us off. I know we're really excited today to talk to you about a launch that you just had. We're going to get to that. We're going to get to the launch. But for anybody joining, right? Let's set the stage for
Welcome in.
Yes.
Come on in. Come join.
Hi. Thank you for being here. Let's talk to them about Aurora first, right? Why am I picking Aurora when I go and look at the database choices in AWS?
Right. So that's a great question. So, Amazon Aurora, one of the unique things about it versus like other open source and databases. So this database is fully compatible with Postgres and MySQL, but it's built for the cloud and it's highly distributed. So what we've done is we have a compute and a storage architecture that is completely disjointed and can scale independently. Right. So your compute can increase independently to the storage, and that gives us the ability to offload some of the key database capabilities like having backups and, the ability to restore from backups or create logical clones of your database or scale the size of your database storage independently to the compute where your queries are running. Right. So this gives us like a really powerful database built for the cloud that's fully compatible and at 1/10 the cost of like other commercial databases. That's why we see a lot of customers come to Amazon Aurora to power their mission critical applications.
Nice. And look, we talk a lot about scaling out workloads. We talk a lot about, disaster recovery, backups, these types of things.
Yeah.
So, when I'm building a workload and I've identified, maybe we can talk too about how, you see customers identify when they want to run things multi-region over just multi-availability zones. Where does Aurora Global fit into this?
Yeah, where's that line? That's, so there are two things I want to talk to you about in this space. And the first one is disaster recovery, right? And one of our principles at AWS is we design our services for high availability, but things fail. And take the unfortunate example of the recent hurricanes that happened on the East Coast. And we were on the coast without a power for a week. So if your data center is in one of these regions, you've lost business continuity for a week. And that's a no-go for many businesses. It could have been even worse, right? Like it could have flooded your entire data center and the data that you've spent years collecting, the treasure trove, right, is just lost in an instant. So, while you have an application that's well architected for having, multi-AZs and is available within that region, what if you want to plan for disaster recovery across regions, right? So in the case of our United States, what if you want to have an application that is operating in the East Coast, but also can recover in case of a, unfortunate disaster using data that's also copied over to the West Coast or any other region in the United States for that matter of fact. So that's what, when customers think about like single region versus multi-region, that's one of the key things that they're thinking about. The other use case, what we commonly hear is, I want to scale, my business globally because, I'm seeing a tremendous business model and I want to take that across the globe. So I have this data that's critical. It's mission critical and I can expand. This data is the power through which I can expand my business globally. How do I do that? How do I build a globally distributed application? Take, for example, a streaming service like Netflix. Like, over the years, they have built an amazing model of having, shows from all across the globe I myself enjoy watching like American movies and Indian shows and Korean bodybuilding and eating, cooking shows, and all of that is basically being, thrown in across the globe, and customers are just signing in from different places and viewing all the same content everywhere, right? And so how do you scale your applications to meet that need? And so
Yeah,
global, yeah,
that
this
makes
is where
sense,
global
John.
database comes in.
Yeah, I think availability really becomes kind of the question that I've seen customers asking, right? When I have a highly available, has to be on, needs to recover from the worst failures possible, right?
Yeah.
Makes a lot of sense to have the ability to fail over to an entirely different region. A lot of customers, though, they are fine with utilizing availability zones because those are highly redundant as well. So I think it just boils down to, from what I've seen, and maybe Simon, you've seen, as a solution architect, some of these workflows that, or workloads rather, that can really benefit from multi-region architectures, things like that. So let's talk about what Aurora Global Database offers somebody who's identified one of those workloads.
Yeah, so global database is a feature of Amazon Aurora. And like I was mentioning, Aurora has this like distributed storage and compute architecture. And what global database does is borrows from the same architecture, where we have our replication servers that we manage as Amazon Aurora, that use the storage layer of your database and replicate data physically from a primary cluster where you have your writer and your readers, to up to 5 other secondary regions that can be anywhere in the globe, right? And because each of these secondary regions can have up to 16 read replicas. So that's a total of like 90 read replicas that you can have across the globe to scale your applications. That's like tremendous power. And because we're using physical replication, I want to talk about why physical, right? So typically when customers think about like disaster recovery or just copying data from one region to another, there were traditionally two solutions other than global database that are very common. One is you could just take a snapshot of your database, so just back it up and copy it to another region, right? But with this strategy, your time to recover your applications would depend on how big your database is, because you have to now recover from this massive data set, right? And your recovery point objective, which is the time when you think about disaster recovery, it's like, how much data could I lose? So this is the time that's measured in seconds. That depends on how frequently you can copy this data, right? Because you're taking it across region, it's terabytes of data. Can you do things incrementally? So this stuff is hard, right? So this solution always sat on the like upper quadrant, where like you had like poor recovery time and poor the recovery point objective for your database. The next thing customers started doing was like, can I just use logical replication, which is essentially replaying the same logs on the database into another region. But that then comes with like overhead on your writer. And as your write throughput starts increasing, your lag will start to increase, because the replaying will start falling behind, and your recovery point objective increases. So with global database, because we're using physical replication, we're able to take the same logs that are just being written onto the database and just ship them over using our dedicated infrastructure to another region. And what you see is no performance impact on the writer, and our replication lags, even with 5-second regions, are typically under a second.
Very cool.
That's the power of global database and the way we've architected it. But apart from that, we built a lot of like functionality to give you managed failover and switchover capabilities to recover any of these secondary regions and promote it to give full read-write capabilities. So in case you have an unfortunate disaster event, you can recover your application in typically a minute. And we take care of managing the entire topology. So even if you do recover any of the regions, we maintain the topology, we make sure the replication is set up properly back again. So the work to really maintain your global topology and have compliance met for like a global topology database is always on with global database because of these managed capabilities. And sure, like Simon is going to cover these, like one of the two capabilities in a demo later as well.
I was going to ask, I know we we've got limited time here. So Simon, do we want to jump in and actually take a look at some of this stuff?
Yeah.
Let's do that. I had a plan for what I'm going to say, but at this point, it feels like unless I make a bunch of candy references, I'll just get kicked out of here. So let's.
I'm already done with candy. Like I finished my. I'm so bad. I finished all my Halloween candy by myself.
Just like Rohan said, so many features, you can carve them out the way you want, just like a pumpkin, to make the shapes you want and use it the way you want. So let me just share my screen real quick, and we will walk you through some of the global database tricks and treats. Well, treats, I guess. So here's a quick start here for y'all. We're going to do a really quick sort of walkthrough, step by step, take it one step at a time, starting with your regular Aurora. No, not now. Starting with your regular regional Aurora cluster. This is kind of a minimal setup where you have your Aurora cluster with just one instance inside of it. This is what you would typically start with. You'd add multiple AZs to it later for any region resiliency. But when you want to start playing around with global database, it's really, really easy to just take your existing environment, take your existing Aurora cluster, and just add regions to it. So you don't really have to rebuild the whole thing from scratch. You can just add regions however you want. And this is as simple as going to your console and just choosing the add region option here. So we're going to add an AWS region to our existing currently single region cluster. And you'll be greeted with your familiar flow. We're going to just give it a name that's global. I'm not going to wait for the thing, but we'll just to show you how easy it is to create it. We are currently actually in North Virginia, so let's go ahead and go across the country to Oregon. You're going to have your typical choices of instance types for your new cluster resources and whatnot. This is all going to look very familiar if you've ever gone through an Aurora cluster creation wizard. So you're choosing your security groups, you're choosing your configuration, and basically all of this is, again, very familiar, consistent with your prior experience, and all you do is hit the button. And it will start automatically provisioning your secondary region. So what you're going to notice is the topology in your console, which is now flooded with messages, is going to show that you actually have a global entity with regions being provisioned for you behind the scenes. That's going to take a snapshot from your existing volume on your existing Aurora cluster and do all the magic behind the scenes. So, it's actual automation, not that there is a wizard behind operating a machine here, like in the references we've already got, but this is going to take a moment. So I'm not going to wait for this one to finish. Just wanted to show you how easy it is to kick it off.
Yeah.
For the next steps. Yeah.
So what you've just shown us is that you had a database that was just regional, and it automatically became an Aurora Global Database when you added another region to it. So that region that you added, that one becomes the default failover region. If you add more regions, can you determine or can you pick which regions you want it to fail over, or maybe in what order?
Absolutely. So when you add regions to your global topology, whenever you want to switch over or fail over, you can choose which region you want to move to. That is all under your control. And you have metrics that we provide as part of the service to tell you which regions have what kind of replication lag, what kind of status, so you can always make an informed decision. Or if you just want to do a sort of a dual region setup like here, you still have a choice, where to go, and you can switch back and forth without breaking this topology. So you don't have to recreate this whole thing after you've done a switch over, after you've done a failover. The topology that you see here right now will remain intact.
Very cool.
So
Simon, I don't know if you're going to cover this later. Please tell me to hold it if you are. But when you're scaling out databases, typically you bucket things into reading and writing to the database, right? These are two very different things that scale differently. How does that work across these multi-region global databases with readers and writers? I know we've got two separate endpoints. Is there anything else that you would consider?
Sure, and I think it's a great segue to kind of talk about one of the new features that we've just announced, which is the global writer endpoint for global database. And I'm just going to collapse it right now just so we don't get too much on one screen. This is one of the clusters that I already had just to show you what it looks like. So in this case, we have, again, a global topology. You have your primary cluster here. You have your secondary cluster in another region. And you can notice that those clusters have multiple instances each. They are all readable. So if you want to have a situation where you want fast local reads for your client applications in secondary regions, you can do it right off the bat. Those are all readable. Extremely low lag, just like Rohan mentioned. We also have really cool features like read after write consistency modes for those secondary region readers. So you can have a certainty to the degree that you want that the data you're reading is actually current. As far as the writer endpoint, like you said, you have one primary region with a one writable instance. And what you used to have to do is you had to, call APIs, figure out who's the primary region, and look at the console and do all that to know where the writer is. So one of the really interesting features that we've just announced is the availability of a global writer endpoint. So in addition to the cluster-specific endpoints for readers and writers, now, if you just go to your global database, you're actually going to see a new endpoint down here, which is your global writer endpoint, which follows the primary region and the writer therein. So you no longer have to describe the topologies kind of through multiple steps, APIs, and what have you. All you need to do to connect to the current writer is to use this endpoint, and we will automatically update it as the topology changes, whether it's you adding regions or you doing failovers or switchovers.
That's really cool. So, and that Jafar did comment in the chat, and he pointed out that this would take months or years to set up on your own without AWS. Finding and testing all these failover cases would take even longer. And so you're saying that this update that you've added now is that the writing is just being sent to one single endpoint, and then the customer now doesn't need to worry about where exactly that endpoint is if there's a failure, because AWS is going to manage the failover. It'll spin up a new writer endpoint, and you don't need to worry about changing that new endpoint because the same endpoint that you have set up will now send it to the new writer endpoint.
Absolutely.
Yeah, and we'll update it. And just I don't know, we don't have a lot of time, but this should be a great sort of showcase for how easy it is to actually do things like failovers and switchovers. So just a really quick recap: switchovers are when you do a clean move from the primary region to a new primary region. We take care of data synchronization. There's no data loss as part of the process. Failover is more something that you use in a case of actual failure of an actual problem in your current primary region. We prioritize bringing up the primary in the new region. We don't guarantee data synchronization as a result of this being asynchronous replication, but it's super, super quick. So let's basically do this. I'm going to do it right now. I have my global database. I'm going to just choose switch over. I'm going to use failover, which is quick. Choose my region, confirm.
Chat, how long do you think this is going to take?
Unbeknownst to you, I've already been pinging these regions behind the scenes. I came prepared. So this is my current primary region. It has a writer on the left. It has a reader, and this is the secondary region that I had, which just has readers. Mm-hmm. We've done the failover request in the background. And so what's going to happen is you're going to see that we will actually promote the new primary region. And it's already starting to happen. And I've only been talking for maybe 30 seconds. We take a best effort attempt to isolate the current primary. We don't guarantee it if the region is actually down. But here, take a look at this. We missed maybe 3 seconds of pings on the secondary region, and it's already a writer. That's done. The failover is over. You are already operational from the secondary region.
Yeah. You were using the same endpoint, I'm assuming? You were using the global endpoint?
And actually, I used the secondary, the global endpoint behind the scenes, and it already switched automatically. Wow. This is just doing DNS lookup, right? So it automatically switched, and this has been, less than a minute.
Wow.
That's impressive.
That was awesome.
And we will now automatically rebuild the original region. No need for you to do anything. Topology stays the way it was.
I love the no need to do anything part. That's one of my favorite parts.
That's actually my favorite part too.
So Rohan and Simon, we're unfortunately out of time, but where can people learn more? We've been dropping links. What would be your suggestion to somebody who's interested in learning more about what you've been doing with Aurora Global Databases?
Yeah, so some of the things we have a couple of neat blogs. Our user guide has all the information that we launched, along with global endpoints. We also launched something new today, on tagging your global cluster. So all of that is also in. So yeah, our user guide, our product display page has all the information, and then hopefully we're going to collect a new blog that has showcases all of these new information that will also custom that you guys can view to learn more about all this stuff.
Amazing. Thank you both for joining us. Chat, go check it out. Go see.
Give it
Go
a
see.
read.
All right. We will see you two next time you launch something.
Thanks so much for joining us. It was great chatting.
Really great chatting.
Thanks for having us.
Finish all the other candy and all because of all the candy references.
Do it.